Alright, so let's pick up where we left off. We completed part C. The directions are to simplify. So now we'll go to part D. For part D, it says we're going to multiply x plus 1 times x minus 2 times negative x plus 2 times x minus 3. So this one's a little bit more advanced. What we want to do is break it up into smaller segments. So let's FOIL these. We'll FOIL these, and then we'll move on to our next step. So remember, with FOIL, we multiply the first terms, the outer terms, the inner terms, and the last terms. So the first terms here would be x times x. The outer terms would be x times negative 2. Then we have 1 times x. Then we have 1 times negative 2. We're going to put this minus sign here, but now we're going to FOIL what's on the inside. Now we have to put a bracket there because whatever this turns into, we're going to distribute negative 1 into the whole thing. So we're going to do x times x, the first terms, plus the outer terms, x times negative 3, plus the inner, 2 times x, and then plus the last, 2 times negative 3. So we have a lot to multiply out, so let's go ahead and do this. X times x, remember when you're multiplying the same base, you add the exponent, so this would be x to the second. 1 times negative 2 is negative 2x. This would be 1x. 1 times negative 2 is negative 2. And then we're going to be subtracting x times x. You add the exponents, that's x to the second, minus 3x, plus 2x, and then minus 6. Let's combine our like terms, and then we'll deal with this negative. We're going to have x squared minus 1x minus 2 minus x squared minus x minus 6. We'll distribute this negative 1. Brackets are the same thing as parentheses. So this will be x squared minus x minus 2 minus x squared plus 1x plus 6. Combine our x squared terms. 1x squared minus 1x squared cancels. 0x squared. Negative 1x plus 1x, those cancel too. And then we have negative 2 plus 6 is 4. Part E is similar. And for part E, we have x minus 2 to the second minus x plus 1 to the second. Now you don't want to do this. That's not a property that we use here. We could use that if we're multiplying on the inside, but we're adding. So we have to do this problem similar way to the way we did the last problem. We'll multiply our first terms together, our outer terms together, our inner terms together, and then our last terms together. We'll put a negative, and we'll put brackets so that we know to distribute this negative into whatever this whole thing turns into. We'll multiply our first terms, our outer terms, our inner terms, and then our last terms. So let's see what this comes out to. X times x is x squared. Remember, same base, we add the powers. And then once we combine all of our like terms, you could distribute this negative in. Combine our like terms. 1x squared minus 1x squared is 0x squared, so those cancel. Negative 4x minus 2x is negative 6x. And then 4 minus 1 is 3. That would be our answer to part E. So let's move down to number 6. Number 6, it's saying graph the solutions to the following sets of inequalities. All right, so we have an equation 2x minus 3y is less than 6. We have another inequality, y is less than or equal to 1/2 x minus 3. Now in order to graph, we want to make sure it's in y equals mx plus b form. So this inequality is all set. I just want to rearrange this so it looks like it's in slope-intercept form. 2x minus 3y is less than 6. We could bring the 2x on the other side. Negative 3y is less than negative 2x plus 6. And divide everything by negative 3. Now remember, anytime you divide across an inequality by a negative, you do have to switch the inequality sign. And now we're able to graph this. Maybe I'll go 7 out in each direction. And I'll graph using different colors so you could track which one I'm drawing. For this first one, we'll start at the y-intercept of negative 2, and we'll go up 1 to the right 2. This is or equal to, so remember, anytime you have an inequality that looks like this, it's going to be a solid line. And it says less than or equal to, less than means we shade below. For the second inequality, we're going to also start at negative 2, but from here we're going to go up 2 over 3. Now this inequality, we dash our line. That means that numbers that fall on this dashed boundary line are not part of the solution. The line's a little crooked, but I'm sure you get the idea. We're going to be shading above because it's a greater than sign. So as far as what the answer would be, the answer would be areas where both lines are shaded. Be like over here. That area has both red and green shading in it. Let's move down to number 7. Number 7, it says write an equation in slope-intercept form through 2 given points. So we're going to write an equation in y equals mx plus b form. And the points that we're going to be using are negative 1, 0 and negative 2, negative 3. Now in order to do this, we need to figure out what the slope of the 2 points are. And we also need to figure out what the y-intercept is, and that'll take a little bit of extra work. The way we find our slope, which is usually called m, is we subtract the 2 y values, and we put that over subtraction of the 2 x values. I always draw arrows, so negative 3 minus 0 over negative 2 minus negative 1 gives us negative 3 over negative 1, which is just 3. 3 is our slope, so I'm going to put that in for m. The only other thing we're missing is a b. Now at this point, you could pick whichever point you want, and we're going to use the x or the y value of that point. Most people prefer to pick a point with a 0 in it, so the first point has that. So instead of y, I'm going to put what the y value is, which is 0. Instead of the x, I'm going to put what our x value is. And let's solve this for b. Bring the 3 on the other side. So we get that b is equal to 3. So combining our b of 3 and our slope of regular 3, what we wind up with in slope-intercept form, we get y is equal to our slope times x plus the b value. So that's the answer to number 7. Let's go to our last page for page 4. Take a look at number 8. So for number 8, it's giving us a graph of y is equal to x squared minus 3x minus 4. Remember, y and f of x are the same thing. F of x just means that it's a function of x, which means it passes the vertical line test. That means it's a function. So for this graph in particular, it looks like this. It goes through -2, it goes through 2. Those are called zeros or x-intercepts. And it goes down to a y-intercept of -4. Now this graph is called a function, and we could therefore write it f of x, because if I draw a vertical line anywhere along this graph, it only hits one spot. An example of something that isn't a function would be, say, if you had a graph that looked like this. Obviously, this clearly hits in 2 spots. That wouldn't be a function, so you couldn't write that f of x. So let's take a look at what this question is asking us. For part A, it's asking us, when is f of x increasing? Well, what increasing means is that means the graph is going up from left to right. So it looks like if I trace the graph, starting right here, the graph starts going up. That's the area where the graph is going up. And that happens, we always say what x values that happens during. That happens between when x is 0 and when x is 2. So we say that it would be increasing on the interval from 0 to 2. If you trace the graph starting at 0 and allow your pencil to go all the way up, actually until infinity, not just to 2, but for the rest of the graph on the right side, the graph would be going up. For part B, it's asking, when is f of x decreasing? Decreasing means the graph is going down from left to right. And we'll use green. Well, if you start here and go all the way down, well, just follow along the graph. You could see you're going all the way down, right? That would mean that the graph is decreasing. So if we start all the way from the left side of the graph, that's called negative infinity. We would stop decreasing once we get to when x is 0, which is right here. Part C, it's asking you, when is f of x less than 0? And what that means is, when is the graph below y equals 0? Well, when we have our graph, this is the line y equals 0. So the graph is below that line, looks like for this segment, right there. And that region goes from when x is -2 to when x is +2. So the way that we write this is we would say the graph is less than 0, f of x is less than 0, between -2 and 2. That's how we write that. And then one more problem to finish up today. It's asking us, when is f of x greater than 0? And that means, when is the graph above y equals 0? So if we take that same graph it looks like right here and right here, those are the areas of the graph that are above the line y equals 0. So the way that we would write this is we would say this piece, we always start from left to right, that piece would be all the way on the left side of the graph up until 2, the graph is above the line. On the right side of the graph, right here, starting at 2, and then if we go to the right, that area of the graph is above the line y equals 0. So for what's the domain, or on what open interval is the graph above, or what open interval is f of x greater than 0, you would say the open interval -infinity to 2. And we put a little union sign to say that that answer is being combined with the answer 2 to positive infinity. We'll finish this up tomorrow, and then you'll have your short quiz.